Hello students, we are going to discuss about 2-bit flash ADC, that is analog to digital converter. Normally we know that there are different types of analog to digital converters are available with us. Out of this we are going to use this flash type of ADC or parallel comparator ADC circuit for our application or for our discussion. Here this is operational amplifier 1, 2, 3. We are going to use IC LM324, which is a quad op-amp IC. We are going to use these 3 op-amps from this integrated circuit. They are working as a comparator. So if you consider the circuit diagram which we are considered over here, all the positive terminals of the op-amp are connected together, and to this we are going to apply the analog input signal. Then if you see here, reference voltage we are going to apply as a 1 volt, and correspondingly the resistive elements are connected in a circuit. If you see over here, at this point, that is a inverting terminal of comparator 1, at this point the voltage generated is this R upon R plus 3R, that is R upon 4R into V reference, that becomes 1 by 4 V reference. So theoretically speaking, this is a 1 volt, 1 by 4 V reference will become 250 millivolts. So at this point the voltage generated will be 250 millivolts. Theoretically at this point the voltage generated will be 500 millivolts. Theoretically at this point the voltage generated will be 750 millivolts. We are going to apply the analog input signal over here, and according to the input signal available at the positive terminal of the op-amp, the output of comparator will be set to high value or low value, and this is applied to 74148 decoder, where at the output side we are getting a 2-bit digital output. The advantage of using flash type of ADC is it is the fastest type of comparator. The only thing is number of comparators required in case of flash type of ADC is 2 raised to n minus 1. Here we are selecting a 2-bit output, that's why 2 raised to 2 becomes 4. So 4 minus 1, 3 comparators are required, C1, C2 and C3. If we are selecting a 3-bit output, then 2 raised to 3, that becomes 8. So 8 minus 1, 7 comparators are required. So number of comparators required may be more in this case, but the circuit complexity is less, and we can convert analog input signal into corresponding digital output signal. The observation table is like this. Here we are having the reference voltage 1 volt as we are going to apply. The analog input signal we are going to apply between 0 to less than 250 millivolts. Then we are second case we are considering greater than 0 to 250 millivolts, means greater than 0, less than 250 millivolts. Second case greater than 250 millivolts, less than 500 millivolts. Third case greater than 500 millivolts and less than 750 millivolts. Third case is greater than 750 millivolts but less than 1 volt, and correspondingly we are going to check the digital output over here. Now let us come to the circuit discussion. This is a plus 5 volt power supply. This is a multiple power supply. From this power supply we are going to apply 5 volt signal over here. This is a 5 volt terminal here, which is the requirement for the 2 ICs. Then by using this 0 to 30 volt power supply, we have designed a 1 volt power supply which we are going to apply over here. This is 1 volt power supply applied, and accordingly here at this terminal 250 millivolt is generated, at this terminal 500 millivolts, and at this terminal 750 millivolt signal will be generated. And here by using this power supply we are going to apply the input signal which is as mentioned less than 250, then less than 500, then less than 750 millivolts and less than 1 volt. Like these steps we are going to take. I will just show you the voltages which we are going to apply right now. This is the 1 volt signal we applied as a reference voltage. This is the 5 volt signal which we have applied for the integrated circuits, and this is the analog input signal we are going to apply. Now the analog input signal right now, is greater than 0 and less than 250 millivolts, and you can see the outputs over here. So both the terminals are both the LEDs are not blinking. Now I will show you the output of comparator. Theoretically output of comparator expected is 0. Practically we are getting here 650 millivolts for comparator 1, comparator 2 and comparator 3. In all the cases, the output of comparator is at a 0 level. So first condition is satisfied that input signal, analog input is greater than 0 and less than 250. The output is 0. Now I will take the second condition. If I am going to increase the analog input signal, analog input signal is greater than 250 millivolts. Analog input signal is greater than 250 millivolts as we have considered over here. Greater than 250 millivolts, and then we will check the output of comparator. So if you see the output of a comparator 1, comparator output is 3.8 volts C1, comparator C2 is again 650 millivolts, so off. Comparator C3 is again off. So when the input is bit greater than 250 millivolts and less than 500 volts, comparator C1 is on and comparator output C2 and C3 is again in off state. So again the condition is satisfied, this LED is glowing. So what we have defined again, now I will connect the input signal or I will take the analog input signal greater than 500 millivolts, so it is 660 millivolts. Now see the conditions, LED is blinking over here. Now output of comparator 1 is 3.8, comparator 1 is turned on, comparator 2 is also turned on, means condition is satisfied, and output of comparator 3 is 650 millivolts, so comparator C3 is still in a off state. If I take the last condition, that is greater than 750 millivolts, greater than 750 millivolts and less than 1 volt. So it is greater than 750 millivolts. Both the LEDs are glowing, means output is 1 1. The output of comparator 1 is 3.8 as 3.8 and this is 3.8. Means all the comparators C1, C2 and C3 are turned on and the output is 1 1. Means when the input signal is greater than 750 and less than 1 volt, output we are getting is 1 1. Hence, as we have defined theoretically, the conversion of analog signal into 2-bit digital output is obtained. Thank you.